Welcome. This is Kimon Onuma and BIMStorm AEC Game Changers. Thank you for joining us today. Today is about a window seat on BIMStorm AEC Game Changers. If you go to BIMStorm.com, you can see the introductory webinar that we had a few weeks ago or a month ago about the BIMStorm. We're happy to have San Jose International Airport and their data and floor plans inserted into the BIMStorm. We'll be presenting that today. And as far as the scenario planning, we'll be going through what we have been prepping for the last 10 days in preparation for this webinar and for the next few months to come. This is about game-changing innovation, and technologies around us have completely transformed our world and how we work. And we feel that the AEC industry is ready for this. We're ready to shift how we work in design, construction, and operation. And that's what the BIMStorm AEC Game Changers is about. We're happy to have a new sponsor, BIMobject, today. And we've had a lot of participation from different groups as well as San Jose International Airport. And thank you everybody for participating. And we invite other participants, whether you're a sponsor or whether you're part of the AEC industry and would like to be part of this BIMStorm, please jump in. And you can do that by going to BIMStorm.com or actually sending us a tweet on BIMStorm, a Twitter account, and say how you would like to participate. We want hands-on participation. The more the better. And we invite anybody in the industry to join us. This is the Twitter website, and we have a lot of activity happening there that highlights exactly what's been going on day to day with this BIMStorm. So we've had some great participation and presentation over the last few weeks, including Michael Chipley. Patrick Crowley from the San Jose Airport was with us last time. He's not able to join us today, but he will be on again in future webinars. Steve Hagan, who started the AEC Game Changers series for the AIA conference this year. Myself, Kimon Onuma. Today we have Jim Bedrick, who's process engineering, Mark Giuliani from Giuliani Associates, and Deke Smith presented yesterday at the Federal Facilities Council, and he shared some slides with us, which we will be showing today, and he will be joining us in future webinars as well. So Deke's presentation yesterday was about the total cost of ownership, and this really fit in nicely with the theme of the BIMStorm. This is something that's being developed at APA as part of the TCO working group. And it's really about looking at everything beyond the initial cost of purchasing a car or designing and constructing a building. There are other costs, obviously, and we don't typically look at those very carefully in the AEC industry, and we think that that is the opportunity. How do we connect the dots and look at the total cost of ownership versus just the first initial cost? And to predict the future, it's not really any magic than knowing that a roof is going to fail in 25 years and carpets are going to go in 15 years. So how do you factor that in to the design and construction and operation of a facility? And even in BIMobject, if you look at their products online, imagine if there was more information about the actual life cycle of the products, how much it's going to cost, for example, for a standard incandescent light bulb versus an LED bulb over time. And then we start making decisions based on that information. So whether it's an individual light bulb or an entire building, or the entire life cycle of a building, there are these stages that have been defined as a draft standard from the TCO working group about the total cost of ownership. The stages A, B, C, and D, and this fits in very nicely with the BIMStorm because we're talking about planning, design, construction, operation, utilities and costs, for example, and then end of useful life. What do you do with it? And an airport is a perfect example to work on for that. So in BIMStorm, we are looking at Big BIM. We're not just looking at the single project or the single set of software tools. We're looking at the entire life cycle and how we can generate value beyond the initial design and construction of a facility, expanding the horizon. And in game-changing innovation, we had a series of great speakers, and today we're happy to have with us Jim Bedrick, who's going to give us some great examples of what's been happening in the building industry as well outside of the building industry and how we can learn from that. So Jim, thanks for joining us today, and are you prepared to switch screens and show us your presentation?
Yes.
Okay, great. Oh, as you're switching, I'd like to let everybody know that's online. If you have questions, there is a chat box in the GoToWebinar panel on your right at the very bottom. A questions box, I'm sorry. If you can type your questions into there, we will be taking them and having a question and answer session at the end. Jim, are you there?
Yes, can you hear me?
Yeah.
Okay. Had to get all the switches set.
Yeah. Thanks for coming.
Okay, thanks. So what this is about, you see the title here, Innovation Without Borders. What are the borders we're talking about? Well, the issue is that you probably, many of you, if not all of you, have seen this curve here that shows the red one is overall business and industry in the United States, with farm industry taken out because farm production has soared in the last few years, and so it would skew that red curve even higher. But that's basically the productivity of overall business in the United States. The blue one then is productivity of the AEC industry. So you can see that while everybody else has just about doubled their productivity, we've remained pretty much flat. So the question then is, you know, we keep having these conferences where we have, you know, the AIA conference or the AGC conference or whatever. Some of them actually expand beyond their particular discipline and get in a broad range of disciplines. But most of the conferences we see are to do with the AEC industry. So the question then is, if these guys have doubled their productivity and we've stayed flat, why aren't we talking to these guys up here? So some of the things that have happened in terms of bringing in innovations from outside the AEC industry. First of all, from the aerospace industry, this is where the virtual reality and all of that came from. Back in the 60s, the Air Force developed heads-up displays for fighter aircraft, so the pilot could look out to see what was outside as well as what the instruments were showing him. Well, there was a young lieutenant, Tom Furness, who was working on this this development for the Air Force Systems Command. When he got out of the Air Force, he went to the University of Washington and started the HIT Lab, Human Interface Technologies. So it started at the University of Washington and then expanded to New Zealand and Australia so far. I believe it may expand further. But these are the labs where a lot of the technology was developed that you see now in the Oculus Rift and the Daiquiri helmets and so on. So that came directly from the aerospace industry. And then from outside the box, I mean, it's a nice catchphrase, but what we're referring to here is that our normal AEC BIM authoring tools deal very well with vertical walls and straight walls and so on. They are very, very tough. It's very, very tough to model something like this in the usual tools, curved, compound curves, organic shapes, and so on. Well, these are the kind of things that Gary does all the time, right? So he said, oh, okay, so what industry does deal with these kind of curves? Well, this industry does. Again, the aerospace industry. They have to model all kinds of curved shapes. So Gary Technologies got a hold of Dassault's CATIA and put a basically an architectural overlay on it, and now you have Digital Project where you can model things like Gary buildings. Now, here's a really interesting one, the integrated circuit design. So what possible application could this have to buildings? Well, first of all, there's just the processes of design and manufacturing. You know, so what do the manufacturing processes by which these things are produced, what do they do that AEC does not? Well, they reduce the variability, they fully integrate their supply chain, and the key point, though, here is that their survival is based on plowing some of their profit back into innovation. And there's a takeaway for us, because not many of us have, not many of our firms actually, most of us consider innovation kind of a side issue and a cost and so on. Well, these guys here, they know that they're not going to survive unless they plow something back in. So if we take another look at in that light, as to the productivity of the construction industry, here we are way down at the bottom. So how come? Well, everybody talks about our fragmented processes, but also the buildings have increased in complexity, but we haven't kept up with that. Up here, where the productivity is high, they use extensively productivity enhancing processes and tools. Okay, so like what? Well, let's take the example of the first transistor on the left there. And then how those are made today. That chip on the right has 2.6 billion transistors in it. So what's the difference here? How can we produce these things now when we built this thing by hand before? Well, that was designed by hand. This chip is designed using electronic design automation. All right. This thing was manufactured manually, the transistor on the left, and the design and manufacturing were separate. Today, the microchip industry tightly coordinates manufacturing and design. This took several days to assemble this first transistor. Now thousands of these chips are manufactured per hour. And we have in the first one, the process that was used for the first one produces a lot of variability in quality, and it's pretty hard to mass produce that. Now we've got the mass production, and it not only keeps up with Moore's law, this is one of the real drivers of Moore's law. So what does that have to do with our industry? If you look at the design of a microchip, things have to get from point A to point B, and in a certain amount of time, because the distance that the signal travels will vary the time, and signals have to arrive at certain places at certain times. So things have to be adjacent, there have to be paths between them, and so on. So maybe you're starting to see a little bit of a similarity here. We talk about traffic paths and adjacencies and so on in our industry. And then if you look at the thing on the left, that is a design for a chip. On the right, we have a stacking diagram of a hospital. And there's some similarities you can see there. Now, in the chip, the EDA approach, electronic design automation, the chip industry is able to evaluate hundreds of variations and virtually operate these and simulate operation in them so that they can pick the most optimal. So an outfit named Aditaz applied that same design approach to buildings. We've got adjacencies, we've got traffic flows, and we can do simulate the operation and pick the most efficient. So if you compare these, then compare a healthcare building with an integrated circuit. All right, they both have high civic value. They're both significant capital expense. Mistakes are costly in both of them, and they're both very complex. But then the difference is they both require coordination across multiple disciplines. Well, how do we do that in our industry? Some of us, and sometimes best practices are documented and recorded. Oftentimes they just simply live in a senior designer's head, and then they're applied ad hoc to new designs. In the integrated circuit industry, these tools are codified and put into the automated design system so that they can be applied next time very effectively. How do we deal with complicated systems? Well, in our industry, we route all of our MEP systems by hand and then we, at best, we put them together in a model and see where they run into each other and start bending things around to make them fit. Well, in the integrated circuit process, data flow is placed and routed automatically. And we're going to get to how that specific one can be applied in a minute here. The rules. There are a lot of rules that apply to buildings, but really in current practice, they have to be filtered through somebody's brain who has to try and remember all of the rules that apply, and then apply them to the design at hand. And again, with integrated circuits, those rules are hard and fast. They can be codified. An example here is what Singapore Building Construction Authority has done as far as automated code checking. They can plug in the rules that govern access and egress requirements and automatically check the building to see if they apply. So these things can be put into automated systems. Operational efficiency. Well, in a healthcare building, we design something by hand and we start looking at the adjacencies and the traffic flows, and if it looks good, fine. If it doesn't, we try something else. Well, in an integrated circuit design, automatically many options are generated, and automatically they're tested for optimization. So maybe can we apply that to AEC industry? Aditaz has done that. And reconfigurability. In integrated circuits, the reconfigurability is inherent in the design. In a healthcare building, not so easily, and yet this is a huge issue in healthcare. I mean, anybody who deals in that kind of design, you know that when you start a design this year, by the time that building is completed, medical technology will probably have changed 2 or 3 times. So what can we learn then from this that can be applied to the AEC industry? Well, first of all, in design automation, standardized libraries of components. A lot of us have that now. That's fairly well established in the industry. But a comprehensive set of design rules to accommodate spatial and physical needs. That's where we haven't really codified those things as well as we could. And if we could, we would be much farther along toward optimizing our designs. Analysis and verification. Okay, so the circuit industry again analyzes hundreds of options and automatically selects the optimal one. We want to carry forward design options in a lean process, but we can't. As long as we're doing those designs by hand and measuring their efficiency by eyeballing them, it's pretty hard to carry very many multiple options forward. And then in manufacturing, they have that direct link from design to manufacturing, which the mechanical trade industry adopted quite a while ago, where they can take their detailing software and generate code to drive the machines that actually fabricate ducts. And then managing the supply chain, thanks to the Lean Construction Institute, we've gone quite a ways down the road to getting a more efficient supply chain in our industry. But that came from outside the AEC industry. So we mentioned there this idea of routing and optimization, not only in terms of layout of floor plan, but then in terms of routing of systems. And this again comes from the aerospace industry. And if you look, you can take a look at this this plenum here. You know, we think we've got it tough trying to avoid all the clashes in there. But look at an aircraft, and all that stuff has to fit into the a wall that's a few inches thick of the airplane. Well, a program was developed for the F-35 program, where they put some Visual Basic on top of CATIA and developed some automatic MEP routing systems. Well, this, an outfit called Building System Planning, adopted this, acquired the IP, and applied it to MEP routing. So the main issue here is that they take these algorithms for clash-free routing. So rather than routing things and then fixing the clashes, they route them. They use heuristic algorithms to route them without clashes in the first place. Well, how is this developing? Right now, automated point-to-point routing is accomplished. They're doing that. The next step is complete coordination and optimization. So it's one thing to get a duct from point A to point B and get it around all of the obstacles between point A and point B, but what about getting the most efficient route? Basically, in a duct, the fewer bends, the less friction losses you have. And then the next is, of course, carrying that on to automated detailing and generation of CNC code to actually manufacture these from the design we just developed. So in essence, the way this process works is you take an architectural and structural Revit file, and in that model, you just do single line diagrams, and that's literally as simple as, well, you know, I want a pipe to go from this point to this point, or I want a duct to go from that point to the other one, and feed that to the system, and it automatically routes and coordinates them, and the output is a Revit model with coordinated MEP systems. So this, if you look at this first one, we have to add a bunch of pipes to this. Well, those pipes were added automatically. The system routed them around any of the obstacles that were in the way. And this system can also do take in point clouds of existing buildings. So we see here a building that has, here's an existing building that we did a laser scan of, and here's an addition where there's a model. And we need to get a conduit from this point here down to this point here. So the routing, you can see that the system routed that and managed to avoid the obstacles that were nothing but a point cloud. So it works very well for adding new systems to existing buildings. Okay, well, here's a really interesting one that a couple of outfits are dealing with. These are some examples from Skanska. They began by using these virtual reality helmets, the daiquiris, and basically doing mixed reality where they superimpose designs and created scenarios on actual construction sites. So they were looking at this and they said, okay, if we look at how we learn things, if we read about them, the author describes the subject. Okay, so we just hear about it. If we watch a movie, we observe the action, what's going on. Well, then if we get to an immersive game, one of the role-playing games, we actually are the subject. So how this was applied to construction safety, there's an example here. They had fixed protocols for unloading heavy loads, okay? They were supposed to be analyzed first, a plan made, and people spotting and so on. Well, in this case, that didn't happen. The guy went to unchain the load and was hit by several heavy steel members. All right, well, to train on this particular incident, you could read about it, you could watch a movie of it, but what they did was create a video game, and the trainee would come in here and say, okay, how am I going to unload this? Well, I'm going to go up and just loosen those chains. And then, whoops, that's what happens. Now, obviously, this is going to be a lot more effective than reading about it or watching a movie. You just saw those steel members fall on you. So this is a case where the trainee became the subject. that expanded back in 2014. Even OSHA adopted virtual reality and gaming technology for safety training. Some of the rental outfits, like United Rental here, have also adopted it. And here is a guy that's training on how to use a lift, and he's actually watching himself place the things that he's lifting here. Obviously, a whole lot more effective than reading a manual. So to sum up here, we looked at this curve earlier, and we can see that it was about in the early 80s where these curves really started to diverge. So the question was then, why? What happened there? Well, it was deployment of technology, really. Most of industry started adopting not only computer technology, but robotics and that sort of thing, and really took them on and increased their productivity by twice. All right. There's a couple of excuses that we've had in the AEC industry. One is we said, okay, well, our safety record is a lot better than it was back in 1964. Well, that's true, but these guys' safety record is also a lot better. We always use the excuse that all of our projects are different, that this is really different from manufacturing. Well, in a lot of ways, it is very different from manufacturing. Those chips that the design, the cost of the design, the investment in design of that chip can be spread over thousands of chips. We can only spread the design over one building usually, maybe 2 or 3 if we happen to be on a template project. But a prime example here is what the Lean Construction Institute did. Ballard and Howell looked at Toyota's lean manufacturing system and said, okay, yes, the AEC industry is different, very different, but there are some similarities. So they took they took what was similar and what was applicable from, rather than throwing out the entire baby with the bathwater, they took what was applicable from Toyota's system and applied it to construction, and now we have lean construction. So the point is then, it may be a far stretch to see some of these technologies like fighter aircraft heads-up displays or integrated circuit design or supply chain innovation. They may be a far piece from the AEC industry, but if you look carefully, you can see things in them that are applicable and can improve our productivity a lot. Bottom line then is that this distance here, this gap, is a huge opportunity. Anybody that steps into this gap, even a little ways, is way ahead of the competition. Okay, Kimon, did you want to take some questions?
Yeah, thanks, Jim. That was great. Yeah, so a few questions and comments. Let me switch back to my screen here. What you talked about is game-changing innovation, essentially, and what can happen with the AEC industry. And you and I both have been very involved with many standards organizations and industry groups like the AIA, the IPD. We were both on that committee, and you started all that, and you've made great. You've been a great innovator and a push for the industry, but unfortunately, I think, and I don't know, this is a question actually for you, do you think that the AIA and architects are changing fast enough? And that really always concerns me by looking at what's happening elsewhere and that we're not applying it. We're kind of waiting to be told what to do. And that gap obviously is an opportunity, but if we don't take that opportunity, others will. What's your view on that?
Well, that's a great point, Kimon, and there are 2 issues there. One is that we often talk about, well, we're going to wait till the owner asks for it, right? We're not going to do BIM until the owner asks for it. Well, the owner doesn't necessarily know. The owner is not an expert in the design and construction industry. We are. That's what we're getting paid for. So we need to be proposing to the owner the kind of things that will help their project. Okay. The second piece is, you saw that piece there with the chip industry where their survival depends on plowing some of their profit back into innovation. Now that is starting in a few people. I believe Mortensen is one of them. Actually have an innovation department. Okay, that's the purpose of the people in that department is to actually find new things. Okay, that I think we have to go there in order to really make any advances into that gap in productivity.
Exactly, yes. And what happens when that gap gets, some parts get resolved and we start automating as much as what you talked about? Automation of portions of design, whether they're very easy parts or whether they become more complex with AI and algorithms, is obviously going to take hours away from the project. And that's been always a struggle, that a lot of the AEC industry are kind of pegged to hours and documents that we produce, not the value that we produce. And that's a constant struggle that I think if we don't solve that, others will, and they won't care that it takes less time to actually configure things automatically. Just like we're seeing with Aditas or WeWork or others, there are areas that are very innovative things are happening, but if we put blinders on, we're going to get run over unless we drive this discussion. And I think you're absolutely right. The owners want these kind of solutions. They don't know how to ask for it, but we have the answers as long as we're willing to share how that happens. So anyway, a couple more comments relating to what you were showing. I think the reconfigurability that you've mentioned, healthcare, but even what we're going to be talking about today with the airports, we're actually going to be talking about healthcare as well too as part of the BIMStorm. But I think any building over time, just like we saw with the total cost of ownership, it's not a static building. It's not a static design, and the tempo of change obviously varies between building types, but there's always going to be change. And if we don't address that, the concept of reconfigurability and the need to change over time, we're really not doing a service to the owners in the industry. I think the role playing that you talked about is exactly what we're doing with BIMStorm. If we obviously, there's a lot of great presentations and conferences about technologies that are out there and case studies, but the way to actually make it happen is to get our hands in the sandbox, and that's what BIMStorm is about. It's about putting all these great technologies and processes out there and challenging us in the industry and bringing the owners to the table and saying, let's see how it works if we take the constraints out. We're trying to make it as real as possible, but also take the constraints out. Obviously, when you get into contracting and all that, it gets more complex, but in the BIMStorm, that's our goal here, is to really blow the doors open and see what can happen. So let's move on, unless you have any final statement, Jim, before we go on. And we'll have more questions at the end if you'd like to stick around. But thanks for your presentation. It was great.
No, I think we covered it. Thank you.
Thanks, Jim. So we're going to move on to the next portion here. I think, just to reiterate what Jim said, I think we're in a crisis mode in many ways. And I was at a conference last week that Barbara Jackson from Denver put on with the Construction Institute and other groups, and we were talking about the crisis that the industry is facing. We really are in a crisis, and if we just wait and see what happens, it's really going to be, it's a train wreck right in front of us, and that's the train wreck that we want to avoid. So I'd like to introduce Mark Giuliani. Mark, are you on from Giuliani?
I am.
Associates? Yeah, say a few words about who you are and what you do as we go into the next section here.
Okay, I will. Good morning, everyone. Good afternoon now. My name's Mark Giuliani. I'm with Giuliani Associates Architects, and we're a firm that's been practicing architecture in the aviation and transportation industry since the late 1950s, and we have been involved in every part of airports, from small coffee shop kiosk all the way up to very large hangars and complicated cargo facilities and terminal buildings. So I think Kimon and I have worked together on several projects, and I'm delighted to be here today to help Kimon demonstrate some of the work that he's doing.
Kimon, we can't hear you.
Thanks, Mark. Just to reiterate, we had Patrick Crowley on from San Jose Airport on our last webinar, and he's not able to make it today, but he will be with us for future webinars. And Patrick actually initiated a discussion. He was watching previous webinars where we were talking about healthcare planning, and he was asking a lot of questions from airport perspective, and we decided to actually make that part of this BIMStorm. And what we want to show you next is what's happened over the last, it hasn't been that long, it's really been about 10 days of time, and you can follow it on BIMStorm.com as well too. We saw this from Patrick. He sent us some documents about San Jose Airport, PDF and CAD files, and we said, do you have any GIS files? And we started looking at the type of data they had. And we said, you start with what you have, and what can we do with that type of information as we put it into a BIMStorm and make a scenario. So we built up these scenarios, and these are actually live on the web, and Mark's team and the Onuma team and others have jumped in and started to run through planning scenarios. Just in the it's amazing how much can be done in a very short period of time when you start connecting the dots and you start taking data and automating things into the model, and then generating what-if scenarios with it, and putting the knowledge of a team like Giuliani has about airports into the mixture, and converting. For example, we looked at the master planning documents that were in PDF format from San Jose, and we saw that they have existing facilities, they have a pretty new Terminal B, and the master plan, there's talk about a 700,000 square foot expansion with 10 new gates, new 9,000 car garage, new 3,000 car garage. And we also identified a clinic that's off-site, a site right in San Jose there that would be a perfect place to land a medical facility, which we are making part of the BIMStorm. So this BIMStorm is going to include, obviously, airport type facility information, but also office space, office moves, renovation of existing facilities, a new healthcare clinic. We're really putting a lot in this mixture and looking at it from a perspective of how do we challenge the industry and actually do things with this. So the next thing we said, okay, what really drives, obviously each facility type has a specific driver. So if you're designing schools, obviously the students and faculty are a driver for that. Obviously in an airport, we're dealing with aircraft coming in, dynamically changing schedules, people coming off of those aircraft, driving the need for space. We need space for larger aircraft that are coming into San Jose. So San Jose more recently started to have a lot more 787s arriving internationally, direct flights from Beijing and Frankfurt and other areas. And that obviously drives a different type of a need at the terminal to support an international wide-body plane coming in, and converting areas in the airport to support that need. These are real scenarios that Patrick Crowley from San Jose Airport gave us. So we have this as a live scenario in the tools that we've been using, the online tools. And just to stress, we're using a whole range of BIM and non-BIM applications, all the way from Google Docs, Google Earth, ArchiCAD, Revit, SketchUp, Onuma system. It doesn't really matter. It's just about how do we connect the dots and make it work with BIM and non-BIM tools and BIM and non-BIM experts. So aircraft people know a lot about how aircraft maneuver and how much space they need to park. As a designer, we need to absorb that information and make sure the terminal can support that. So that's one scenario, terminal renovation to support different type of aircraft, and the optimization of the schedule and the arrival and departure of aircraft to optimize a terminal and make it a good place for the passengers to come in and make it a good place for retail to support the passengers' needs. All that is a reconfigurability challenge, just like Jim said. Everything is going to be moving target, and we don't know what's going to happen 1 year from now, let alone 2 months from now, or even 2 days from now. So in the BIMStorm, we also looked at airline schedules. So imagine, and there is data like this online that says here's an aircraft coming in from Beijing. And we actually did this live the other day. This was as the plane was coming in. We were doing a what-if scenario with that live data, saying the plane is delayed an hour or coming in an hour earlier and needs to park here at this gate. What does that look like? So taking schedule data that already exists and injecting it into BIM and color coding yellow, meaning an aircraft coming in, color coding red, meaning an aircraft getting ready to depart and people waiting in the lounge for that departure. That has a huge impact on how you plan and design facilities. And then, Mark, maybe you could jump in on this. From another perspective, looking at the DNA of what does it take to put an airport together. If you break it down, there's obviously aircraft and their need to park, but there's also the need for lounge areas, holding rooms, support facilities. And Mark, you gave us a lot of input and actually started building up these templates, which we have been working on for years actually, but now we're exposing more of that process as part of the BIMStorm. Mark, would you like to say something on this?
Right. So airports, as people who work at them and design them and build them know, are very complicated facilities. And where it starts at the curbside and you have to handle baggage and you have to handle security and everything, here we really focused on the gate and what drives the demands that airlines and airports have with gates. And some of the new things in the industry are the common use gates. So how can these be adjusted on the fly as different size aircraft come in? And it's the size of the aircraft and the passenger count that starts to really drive what determines the size of the hold room, the size of the concourse or the circulation, and how you move these passengers through there. And then there's also the revenue generation side, where more and more airports are focusing on revenue from concessions. So what we did was we took data that we've been building up over 50 years of time and data from the industry, and we started to put that into a spreadsheet and analyzing the different types of aircraft that fly into San Jose. And primarily there were the 737s and the 777s and the 787s. So you had a mixture of narrow body and wide body. And we started to develop two different types of hold rooms for that. And what you see on the screen right now is a narrow body on the left and a wide body on the right. And then you see some of the kits of parts that we put together to format and determine how large these hold rooms have to be. So if you have 150 passengers and you have a load factor of 90%, you're going to have a hold room that's going to have to hold approximately 140 people. And when you add up all these hold rooms, how much circulation space do you need? How do you handle all the fire egress? Are you going to have moving walkways? So we came up with different size concourses. And as these kits of parts are put together, you can start to assemble them and determine how many aircraft you can handle, what kind of aircraft can be handled on certain types of gates. And so these are just starts to be what if scenarios. What if we start to load dual load a corridor? Can we handle 2 narrow bodies for every 1 wide body? How do we handle the concessions? How do we handle the circulation around the concessions? How do we drive revenue to the airport? And so these are just some of the things that Kimon's showing here. The kit of parts includes other things other than the actual hold room, but all the utility spaces. So not only do you have the concessions, but you have the restrooms, you have the passenger conveniences, you have retail space, and you have the vertical circulation spaces.
Yeah, that's great. And actually one point I'd like to make is if you look at the spreadsheet on the right, this is an Excel file, but it could have come from a database, but it's basically data that drives space. And for some of you that have seen the previous webinars we've had for healthcare facilities, it's the same thing for SEPs to BIM and program to BIM. It's essentially data driving space. And if that data changes, the space should change. It's kind of a simple concept, but a lot of times what we're doing as architects is we're manually digging through information like this and creating a static CAD or BIM file for the design. We're flipping that around and saying, what if the data actually drives this? Because if you go to a different airport or if you have a different business need, some of these rules are going to change. So for example, the aircraft wingtip to wingtip distance, I might be using the wrong terms, but that might vary by airport or might vary by country or might be all the same. We don't know. But if we start capturing that, that drives how much space do we need between the aircraft, which drives how much lounge area can we put in the terminal, which drives how wide can that space be, which drives how much circulation do we need as aircraft starts coming in, which is driven back to that schedule that we were looking at earlier. If this area of the airport is very crowded at 5 p.m. and all the aircraft are coming in, do we have enough circulation space and can we reschedule more aircraft into that area? A lot of very simple concepts in many ways, but very dynamic and a huge amount of data. And I want to stress again that what you're seeing on screen was done just in the last 10 days or so. This model, and we'll show you live a little bit more later on, but this model, this configurable modules were used to rapidly configure a terminal, and then it was exported to Revit, ArchiCAD, and even SketchUp. So in our world, we don't care what tools are being used as long as they're talking the same language and able to visualize. And here's the actual aircraft that are coming into San Jose: Lufthansa, Southwest, and ANA 777 and a 737 and an Airbus A340, I believe it is. And inside the terminal, you see the spaces that Mark was describing with the actual seating arrangements, the prototypical seating arrangements that could be used to rapidly block and stack and then go on to more detailed design. So the new terminal, the 700,000 square foot terminal, we use these modules now and are actually started stacking them to see, can we fit 10 aircraft or 11 aircraft, or how many wide bodies can we fit, and how configurable can it be for different types of aircraft going into here. And then from a total cost of ownership perspective, as you're even doing this early design, you can start generating, well, this is how much it's going to cost to operate and maintain this facility. This could be a rule of thumb, or it could be very accurate in many ways. If the airport San Jose already has existing data from their current Terminal B, you can apply it based on square footage or people or whatever count to start generating, well, this is probably the range that we're looking at as we start making design decisions. So as Deke presented yesterday, it's these initial, very early decisions that are made that have a huge impact on the total cost of ownership and the life cycle for a new facility. But also, as we reconfigure an existing facility, this is Terminal B, this is an actual scenario that was set up by San Jose Airport saying, Terminal B, we want to park 2 new aircraft at the end of the terminal. This is, I guess they're getting more aircraft coming in. They're planning for actually building 2 new gates before the 700,000 square foot expansion goes. This layout might be the wrong initial layout, but the driver is 2 aircraft. How do we park it here? Do we have to change the existing gate? Do we have to expand something? Do we need a staircase here? All of that was actually one of the scenarios that we're planning. This is scenario 4. Scenario 5 is downstairs on the first floor in the support facilities. These are the office spaces that support the aircraft and the different airlines that are down there, and they're constantly moving offices and spaces and equipment, and we're going to be doing a reconfiguring and moving of equipment downstairs. Then we're also going to be looking at equipment going in. This is actually from BIM object to Sloan Faucet, and we're running through facility management scenarios. Now that we have all this data in, we've converted it to Kobe. We also have a facility management app called BIM Genie running on top of this, where we're actually submitting work orders. So we're slicing across the entire life cycle and saying, what happens if this data is configured in a way that could immediately be used for facility management, either in the existing facility or in the new facility. And we want to really test this out in the BIMStorm. So we have this ready to go with facility management and work orders and technicians responding to work orders and the actual generator rooms that we've identified in the building, and the type of generators that could be there and how do you maintain them over time. And all these interfaces are ready to go and to be used for those that join the BIMStorm and declare what you can do with us. We can actually give you access to this, and we can run through some scenarios. So the question comes of, why would anybody want to be part of this BIMStorm? First of all, we're pushing the envelope and demonstrating what is possible. We have owners that are looking in on this. We have conferences that these are being presented to. So if you become part of this, you learn, and it's free to participate. We're obviously looking for sponsors, but more importantly, we're looking for active participation. You can still watch if you want, but the way to be part of this is to actually be part of that role-playing game that, like Jim said, if we can do this role-playing in with real data, then you become an expert and you can turn this into a value that you can add back into your portfolio of capabilities that you provide to your clients. Or as an owner, we're looking for other owners. If you have another airport or a healthcare facility, we'd love to hear from you and become part of this BIMStorm. This is the gate scheduling scenario. So now that we have the building in, we know which flights are coming in, we have a flight schedule that is a database online, we can start driving what does it actually look like at 5 p.m. in the afternoon with those gates. Yellow means arriving flights, red means departures, and as the schedule changes, it basically just sucks in the new schedule and spits out a new BIM with this configuration in the BIM. And the total cost of ownership scenario is scenario 8. With Deke's guidance, we're going to be looking at how to insert those stages of total cost of ownership into the initial planning of the new facility and the renovation and the maintenance of the existing facility. And we're also going to be including scenario 9, the planning of a clinic, which some of you have seen. We'll be inserting that into the BIMStorm as well. And what I'd like to do now is actually show a little bit of live view of this data to emphasize this is not just a PowerPoint. This is actually the live data of the existing condition. You see the existing facilities there. And we have, if you drill inside the existing facility, you can actually see the layouts. We have the BIM, GIS, and CAD files of all this. All this is in Revit, SketchUp, ArchiCAD, whatever format you want. This is the scheduling data that I talked about. So if we go at 7 o'clock at night, you see a lot of flights coming in. Yellow means arriving flights. That means obviously it's going to be pretty crowded there. You'll notice that at 7 o'clock, a lot of the Southwest flights coming in here. The international flights actually come in closer to morning or afternoon. So I think at 1 o'clock, for example, there's a flight coming in right there. I think that's the Lufthansa flight or the British Airways flight, and there's a flight departing. At the same time, we also have captured other information on all this, and I'm kind of going through this quickly because for those that jump in, we'll give you access to this data live so you can actually see the departments and the floor finishes. We've documented a lot, and we've gone through and taken over 400 photographs inside the terminal and even linked to data directly from the site here. So if you go to any of these rooms, for example, we have links even to our photographs as well as to the Google map view, the 360 view inside the terminal, so you can actually see what that section of the gate looks like. Pretty powerful stuff when you start using what is available and working with that. The last one would be the aircraft scenario. So if we go into edit mode, this is a web tool. This is actually one of our tools, but we'll give access to those that jump into this. Here comes a 787. Where do we park this? Here's the 2 new gate scenario requirement from San Jose Airport. We need to fit this somewhere here on this side of the terminal. Where does it go? Can it go right here? Okay, if we park it here, then we have holding rooms there. Can we possibly say that we don't really need this to be all a corridor here, and we can stretch the holding room over? So you can do dynamic kind of planning like that of saying, let's stretch this out over here and pull this over here. The reason this moves so quickly when we start collaborating is these changes that I'm showing here, Mark can see the changes immediately, for example, and we can collaborate wherever we are in the world and say, what does this look like? We don't need a full-blown heavy BIM model to be able to do this. It's basically quick configurations, but embedded in these shapes are going to be all the information that we talked about to go into the detailed design as needed. Here's a new 700,000 square foot terminal, again with configuring how do we park this aircraft based on Mark's modules that he showed earlier. Modules side by side, we have some extra space here, maybe we can put more retail in there, and we go from there. So it's quick what if scenarios to do that game playing, the role playing that Jim talked about.
It really, Kimon, it really works in both different types of airport formats, whether you have a large airline that has leased a number of gates and has different flight schedules that are changing because of international flights that they're going after, or if it's more like San Jose where there's common use gates and they're trying to generate as much revenue each hour off of each gate, they can on the fly change those gates to different airlines and increase the airport's revenue. So it's very important. This tool really helps those situations.
Right. So it's about all these tools, but also about the process that's being developed here. So for example, we'd love to have, and we've had this in previous BIMStorm, participation from the builders out there. Imagine as we're doing this configuration, if we could start getting some early cost estimates of what's it going to cost to renovate something like this, or what's going to cost to build a 700,000 square foot terminal that looks like this, or from other engineers, cost engineers or specifications. Whatever kind of specialty you have, if you're willing to plug your capability into this, we'll highlight that capability and demonstrate it back to the webinars and the conferences that we're going to be doing through this. Okay, so we're getting close to the end here, but just a few things. In a few weeks, Steve Hagen and I are going to be presenting at the USC What's Next BIM conference, yearly BIM conference, and today's the last day to register at the lower price. It's going to jump up, I don't know, like $100 or whatever tomorrow. So for those that want to attend, it's going to be on the 14th, and there's a link right there at the bottom. Maybe Young, you can put the link in the chat in the question box, or we'll be sharing this presentation with those that have signed up. And this is about plugging into the owner's mind. It's the same theme there. And we have this website for the AEC Game Changers, which we're constantly updating with new information. And the BIMStorm.com site. You can go there to find information about these BIMStorms, as well as sign up for the next webinar, which is going to be a month from now. We're heading into the fall in September, where we're going to be actively showing more live design exercises online. We're kind of setting this up with the webinars to give you a glimpse of what's happening as we build up the teams here. So please go to BIMStorm.com, and for those that would like to participate, please send a tweet to @BIMStorm and tell us what you can do, and we'll plug you into the system. So our next webinar is scheduled for July 28th, Connectivity Standards and Accelerations, and there's another one in August, and in September we're going to increase the tempo here and actually get more live interaction going. Our Twitter page, and that is pretty much it. There's a few questions and comments coming in here, so let me go back to the beginning here and thank everybody for joining us here. The presentations are going to be shared. If you signed up for the BIMStorm, you can get access to this recording. We really encourage you to be hands-on participants as much as possible. You can watch if you'd like, but please follow us there. And there's participants from around the world giving comments here about they like what they're seeing, they'd like to participate more, that's it pretty much. We had a great discussion with Jim. We're close to the top of the hour here. Mark, would you like to say anything as we sign off here?
Well, thanks for having me and being a part of this, and Giuliani Associates appreciates the opportunity. I think it's a really powerful set of tools that help designers and airport operators and airlines understand all of the data that they have, the equipment that they have, and it becomes very easy to move this around and play what-if scenarios, and then bring that data into other building information modeling software, and then have the owner can use it very easily after construction to operate their facility. So it's really, all in all, it's a great tool, and we're happy to be part of this.
Great, and thanks for sharing. That's the most important thing. A lot of us in the AEC industry, we hold things very close. Obviously, we have to make a business out of what we do, but we believe the more we share and the more we can connect here, we can change the way the industry works. Just like Jim said, it's really time to close that gap. And for those that are willing to do that, this is the opportunity to try it out. And obviously this can apply for real projects as well, and we really look forward to continuing this. So we're going to sign off. This is Kimon Onuma, Onuma Inc., and the team here that presented today. Thank you, Jim Bedrick, AC Process Engineering. Thank you, Mark from Giuliani Associates. Thank you, Deke, for sharing your slides. We look forward to your participation in future webinars, and we look forward to the others that have participated as well. Thank you very much. We're signing off.
Thank you. Have a nice day.
Thanks.